Okay, now let me talk about a very important um, detail here. So slicing. Slicing is often also known as the information loss. So the question is that when can slicing happen because of the inheritance? So suppose I have a void func and I am taking note that it is passed by value, and then I have different things inside the function. And then I do a derived d and I call func on passing in d. So now tell me, so this you can notice here, this is what? This is passed by value, right? No pointer or reference here, correct? So when you are invoking this func, passing in this object d, what do you think is happening here? So what kind of copy constructor gets called here? Is it the copy constructor for derived or for the base? Which one gets called? Because pass by value means copy constructor is going to be invoked, right?
Isn't it not the base?
Exactly. I always find it beneficial to always write down very explicitly. When you are passing in D, it is equivalent to writing the formal definition, right? Base B, this is the formal definition, equal to actual, which is D, right? So you can see it very clearly now that it is the copy constructor of the base that is going to be called. But you're passing in D. Now, what does this mean? This means that, remember, derived is base plus something, right? This whole thing is derived. So if you are passing in D and you're invoking the copy constructor of B, the only thing you have the luxury of copying is only this portion. And therefore, this portion would be lost. And therefore, this is called slicing. Is that clear? So this is the slicing way of passing things. The lossless way of passing the derived class would be like this. So either you can pass by pointer. So you can write void func base star b. And then here, now you do derived star d equal to whatever new, and then you pass func d. This is not a problem because what does this mean? This means base star b equal to d. Is that clear? So it just means that dynamically, so this is dynamic type, and this is the static type. So same principle applies what we just talked about before. And the same rule applies when you have a reference here and you have derived. So whatever we talked about in the context of pointer also applies to the reference, sorry. So if you have derived d equal to something, actually not equal to something. If you just have derived D, the instantiation, and you do func passing in D, this essentially means you're doing base ampersand B equal to D. So again, this is the dynamic type, and this is the pointing out the static type. So all the non-virtual method would be with respect to the static type, and all the virtual method will be with respect to the dynamic type. So when you are doing here inside this function, remember the b dot f2, then it would be calling the dynamic type, the virtual methods corresponding to the dynamic types. Okay, I hope this is clear.
So just to clarify, when you initialize derive D, right? That automatically like
This is static.
so automatically you would have all the information for the base
This is
plus like the
constructor for
additional.
D is called, right? This means constructor for D is invoked, correct? Or derived is invoked at this point, right?
When you invoke the derive, doesn't it also automatically like you inherit the qualities of the base, right?
Exactly. So you have base and then you add on extra whatever is there in the derive. This is your derive, right? So when you call the constructor, you constructed this whole thing, correct? Now the question arises that when you are passing in by reference, right? What happens inside the function? Because this can invoke b dot f1, it can invoke b dot f2, it can invoke b dot f3. So which one is getting called? That's what we are asking. So here, when you're calling f1, so we ask the question because this is a non-virtual function. Therefore, it is determined by the static type, which is base. So the basis f1 will get called, right? And when you're doing b dot f2, because both f2 and f3 are virtual functions, therefore it is based on the derived class, correct? Because that's the dynamic type. So therefore, both f2 and f3 will be called from the derived class. And another point that we established here is that it is a complete lossless way. There is absolutely no slicing here. Here, there is a slicing going on. And we explained why there is a slicing. Because it invokes the copy constructor for the base. And the base is only this much.
So when you're using the dynamic type here, there's nothing in the heap though. This is all in the stack.
What is all on the stack? So when you have just this, right? As far as B is concerned, right? This is just a function parameter. So therefore, when you are getting in the function, yes, the pointer B is going to be allocated on the stack, but that is just a pointer B. But what B points to dynamically is going to be D because it's B base star B equal to D.
But D doesn't have to be in the heap though.
D is on the heap because D by definition was derived star D equal to, now you're asking whether it have to be? No, it doesn't have to be, because you may have taken an address of another, sorry, I don't know why it is writing like this. So here, this statement, I put dot, 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 right? So you're right. If this dot, dot, dot is something like new derived, right? Then this is determining that I'm on the heap, correct? But if I have done derived D2, right? And I come here, I say derived star D equal to address of D2, right? So this D2 is allocated on the stack. And therefore, in that case, it points to the memory which is allocated on the stack. So whether this is allocated on the heap is completely determined on how this D is, or where this D is pointing to. It may point to the heap, it may point to the stack. It's just a pointer.
But in terms of what you're talking about here between the avoiding the slicing,
Yeah.
it doesn't matter where D is. It just
Slicing is
matters.
based on the slicing is based on the fact that this was passed by value. There is no pointer or reference. Because this is not pointer or a reference, you are going to have to invoke a copy constructor. And because this is base B, it's going to invoke the copy constructor for B. And because it's going to invoke the copy constructor for B, B is only smaller portion of D. And therefore, the rest of the portion will be lost. Is that clear?
Yeah, I think what I'm saying though is that when you're using the static and dynamic parts of this, the heap isn't necessarily involved in this. It's more in terms of saying that one is the static is, I don't know if I have the right words for this. The static is from the base, is from the what's on the left, and then on the right is the dynamic.
Yeah.
No matter sort of where in memory it's the pointer is pointing to.
Correct.
Whether it's pointing to the stack or whether it's pointing to the heap.
Correct.
But on the right is always considered the dynamic.
Exactly.
Okay.
And why right is considered to be dynamic? Because the pointer has that flexibility to point to anything, right? So how would you know what it is pointing to? It is based on what is there on the right. Okay.
Cool. Thank you.
So, good point. Thank you very much. Any other questions, comments? Otherwise, we will now move to the lab 1.
Wait, just another quick question. So
sure.
Because you initialize for the second part, like derive star D, when you pass it into function, the function knows that it has to call b dot f3, basically.
Here you're talking about?
Yeah.
So when you are inside the function, you're looking through the lens of this parameter, right? Because you have what is in your context. What you have in your context is really the what you have defined at the interface. This is your formal parameter. So everything is going on with respect to that. But because here we have the polymorphism in action, therefore it gives us the flexibility to have this F3 dynamically switch to any object which is part of the virtual function hierarchy. And that is the beauty of this whole polymorphism. Okay. So wait, at the time when I'm writing the func, right?
Yeah.
I am kind of aware that when I'm calling this b.f2, right? This b.f2 can be any of my animals. Like if I talk in terms of the animal hierarchy we drew, right? So if it is a dog, the dog will know what F2 to invoke. If it's a cow, the cow will know what F2 to invoke, you know? And I don't have to worry about it. The function will get done. All I need to do here is that I want to make one of the animals eat at this point. And I don't need to carry the headache of knowing how each of the different kind of animals performs the action of eating. That's completely up to them, how they're going to eat. So here I'm just saying that whatever animal you are, just perform the function of eat, and I'm done. And that is the beauty of the polymorphism, that it just delegates the responsibility of performing the function to the object which is most aware of how to execute the function. And I do not have to know too much about the details of every single class. The class knows how it is going to perform that function, and I'm simply delegating here. Is that clear?
Yeah, I think it'd be clear if we have like a more concrete example later, but yeah, most of it makes sense. Thank you.
Okay, so you will get to the lab 1 where there will be a concrete example.